Advanced oxidation is a treatment process new to the water industry and is not widely deployed in the United States. The newness of this technology requires that pilots are performed before any treatment is conceptualized or deployed at our sites. With the large quantity of clients that have experienced detections of these emerging compounds, a significant pilot study program was about to be undertaken. H2M worked with the numerous technology vendors in the industry to understand what technology could be used to solve these challenges. In particular, H2M focused on peroxide and low-pressure UV light as a forerunner in the technology. You're about to meet Andrew Manfredi. He spearheaded the pilot program for us and worked with the vendors to establish a matrix of solutions that would be necessary to design the treatment for our clients.
My name is Andrew Manfredi. I'm a project engineer with H2M, been a project engineer here since 2010. Advanced oxidation processes, or AOP is what the generic term is really a reference to using oxidation to treat various contaminants in drinking water. AOP design criteria hinge on three factors to provide sufficient treatment: UV dosage, oxidant dosage, and the scavenging term. Each one of these parameters intrinsically affects the other in determining the required treatment levels for 1,4-dioxane removal. The best AOP systems are able to leverage each of these parameters to both dose UV and oxidant in the optimal combination to meet treatment goals at the most cost-effective solution. H2M's pilot testing team has piloted 6 different AOP technologies, ranging from biological treatment, low-pressure and medium-pressure UV light systems with varying oxidants, and a photocatalysis AOP system. We have performed over 40 AOP pilot tests with a low-pressure UV hydrogen peroxide AOP system with varying groundwater qualities. We know which AOP treatment is best suited for your specific water quality. But more importantly, we know what factors in the water quality adversely affect AOP treatment. Our extensive water quality data collected over the course of pilot testing has helped our firm hone in on certain parameters that we know significantly impact AOP treatment performance, and knowledge that can be applied across any water quality found in the US. I started to get involved with AOP pilots back in 2014 with the Bethpage Water District.
We started in 2014 on our first pilot project for 1,4-dioxane emerging contaminants. The approach we took, we passed an emergency resolution. We were very sensitive to the needs of our community, the needs of our water quality. I don't think I would have changed a thing.
The Bethpage Water District was chosen because of the levels of 1,4-dioxane that was found in the well during UCMR3 sampling. 1,4-dioxane isn't really treatable by traditional methods that have been used on Long Island or in drinking water in general. Packed tower aeration doesn't treat 1,4-dioxane. GAC doesn't really treat 1,4-dioxane. So we needed a new treatment technology that would work with the source water to also treat 1,4-dioxane. The immediate need is that we knew 1,4-dioxane was going to be an issue at this plant site, and we knew we needed to treat it, and we needed to find the best available technology to treat it. The relationship with the Bethpage Water District was one of mutual, I think, mutual beneficiary, if that makes sense. Where we were able to kind of learn and understand the process, they were also learning with us.
It's been like, a brother-sister, kind of relationship. I mean, we've bounced things back and forth from each other, and we've learned a lot. So we grew this whole process, we grew together.
The challenge is, and was, that the emerging contaminant was not known. So when the governor and the DEC brought it to the attention of the public last July, that this is an emerging contaminant, 1,4-dioxane specifically, that would be treated for. The following day, after the public comment period, myself and my 2 fellow commissioners and the chairman did meet, and we passed an emergency resolution regarding the treatment. And it was a big picture move on our part. And from there, we met with our engineering firm, with H2M, to try to help us hone in on exactly logistically how we do that. But this was a new contaminant, so the technology involved, we really looked to our engineers and their expertise.
The project, state-of-the-art. It was done in record time. It's some of the most advanced technology implemented into the water industry in decades. The experience, it's been quite fun. It's been a roller coaster. We've learned a lot, and the public's health has been our #1 priority.
I would be remiss if I didn't add in the fact that Rich Human and the entire team at H2M at least with my experience in Bethpage, go above and beyond. This to me always felt like it was more than just, okay, let's just get this done and get our check. It was getting this job accomplished, understanding the importance, because let's face it, this is our lives here. We raise our families here. My children drink this water. I drink the water. My home values. There's a lot at stake here. It's very refreshing. Over the years, very impressed with not only Rich, but the entire team at H2M.